In this video, we'll check the continuity of piecewise functions. That means if the function is given in this form, that is, the function is defined differently at different points. So to check the continuity of this function at the point -1, again we'll check those same conditions. That means first we'll have to find the limit, and then we have to find the value of the function at the point where we have to check the continuity, that is -1. So to find the limit x approaches to -1 f of x. Now here when we say x is approaching to -1, that means x is very close to -1, but x is not equal to -1. That means we will use this value of f of x when x is not equal to -1. So limit x approaches to -1. You don't need to write this at every step. I just wrote to explain it. So I'll use this value now, x squared plus x divided by x plus 1. Now here if I use the direct substitution method, I get 0 over 0 form. As you put -1 at the place of x, this is +1, -1, 0, and in denominator also if you put -1 at the place of x, you get 0. So here the direct substitution method fails. So I'll try to simplify the function. So if I take x common in numerator, what do I get? X into x plus 1 divided by x plus 1. Now I can cancel the like terms, as here x is not equal to -1. So I can cancel out these terms. So what do I get? X approaches to -1 x after cancelling these terms. Now I can use the direct substitution method here, so I get -1. That means the limit exists. Now I have to check the second condition. That means I have to find the value of the function at -1. So f of -1. Now the value of the function when x is equal to -1 is given by 2. So we don't need to solve this part, it's given 2. Now this means the function is defined at -1, but the limit and this function at the point -1 are both not equal. That means I'll write as limit f of x when x is approaching to -1 is not equal to f of -1. Then f, it implies f is not continuous at the point -1. Now this is our second example of a piecewise function which involves a constant a, and we have to determine the value of this unknown constant. We have to find the value of this constant, and we are given that the function is continuous at this point. Now in this case we are given that the function is continuous, and we have to find the value of this unknown constant a. So as we are given that the given function f is continuous at the point -2, that means we can use two definitions of continuity because we are given the function is continuous. So both of those two conditions must hold. That means the limit must exist and the function must be defined at the point -2 where we have to check the continuity, and both of these are equal. So what we'll do, we'll find both these values and we'll equate them, and then from that we'll find the value of a. So let's start. First I'll find the limit x approaches to the point -2 f of x. Now when x is approaching to negative 2, that means x is not equal to negative 2. X is just approaching to negative 2 from both the sides. So I'll use this value of the function when x is not equal to negative 2. So f of x is x squared plus 6x plus 8 divided by x plus 2 when x is not equal to minus 2. That means when x is approaching to minus 2. Now here if I use direct substitution method, it fails, as I'll do it over here. If I put negative 2 at the place of x, I get 4 minus 12 plus 8, and in denominator minus 2 plus 2. So 12 minus 12, that is 0 over 0 form. So here the direct substitution method fails. So as this is a rational function, I'll try to make the factors. X squared plus, if I split 6x, I can write it into 2x plus 4x plus 8 divided by x plus 2, as if I add 2 and 4 I get 6, and if I multiply 2 and 4 I get 8. So I can write it as x plus 2. I took x common from these two terms. So x came out, x plus 2 is left. And from the other term, I will take 4 out and x plus 2 is left. X plus 2. Limit x approaches to negative 2. Now here I can take x plus 2 out from this whole term and x plus 4 is left. X plus 2. Now here as x is not equal to negative 2, I can cancel these like terms. So limit x approaches to negative 2, x plus 4 is left. Now here I can use the direct substitution method. So what do I get? Negative 2 plus 4. That means 2. That means the limit of this function is 2. Now I have to find the second part. That means I have to find f of negative 2. That means the value of the function when x is equal to negative 2. So it's given by a. Now we are given that the function is continuous. That means these two conditions are equal. So if I equate these two equations, that means as limit x approaches to negative 2, f of x equals to f of negative 2. That means the limit of this function is 2 and the function at minus 2 is a. That means the value of a is 2. So this is how we find the unknown constants when we are given the function as continuous.